Hey guys, it's been about 2 years and what feels like 100 projects since I last uploaded a video. I'm going to leave a proper update on all of my other projects for separate videos, but in short, the electronic nose works. We now are able to measure gas mixtures and figure out things like the content of methane, oxygen, CO2, and that kind of thing. But we're still trying to make the leap to kind of identifying solids and liquids. I've also built a few other devices. So for example, here, this is a calorimeter, and I've managed to build that and all of the things that it needs. So it has a main board, firmware. It's basically an Internet of Things device. So I even have a website where you can control it and browse all the data for it. But that really does deserve its own video. But today, for this kind of first video back, I really wanted to share this. So what this is a flight computer from a rocket. So I found out last week that my university has a student society that have been building and launching rockets for like the past year or so. And they're really cool people, very passionate. And they were kind enough to show me their setup, the rockets they were making. And while we were talking, they mentioned that this flight computer wasn't working correctly. They were saying that essentially it drew too much current and that the microcontroller was getting warm to the touch. So let's get it on the bench and see if we can fix it. So let's take a look at this flight controller. This board is the Eggtimer Quantum A18. You can see it's quite a compact board, right? This thing's quite tiny, barely wider than this ESP12F chip that's the microcontroller for it. Got a few cool features inside of it, okay? So we have this micro with Wi-Fi, so that's how you configure and control the system. It essentially sets up a hotspot and a web page that you would connect to that then allows you to control all the peripherals that are here. You've got a buzzer that's for, I think, just audio feedback on launch and so on. You have this small device here that I might be able to get us to see. Well, you can see there's a small hole in it, and that's a barometer. So that measures ambient air pressure and tells you, essentially it's used as an altimeter to tell you how high up the rocket is. Now, part of the rocket recovery is releasing chutes, and so that's what this seems to be for here. I mean, I guess, because I'm not an expert on this, but you see it says main, and then down here you can see there's a drog, that must be drogue. So I'm guessing it's a drogue chute and a main chute release mechanism here. This is a MOSFET, and these two are transistors, and these transistors seem to be wired out to, see, there's the two transistors. You can see they're wired to two of the pins on this here, and the other two pins come out towards this MOSFET. And then this MOSFET seems to kind of ground, I guess, these two. And we have a couple more power circuits over here, power components. They are diodes, right? And they say rect, so these look like they're rectifying diodes. Now that seems a little strange. Given this is a battery terminal, you wouldn't expect to rectify anything. So I think this is just protection circuitry, essentially preventing reverse polarity. But that doesn't explain why there's two of them. So there's a little bit of a mystery there to me about what those diodes are really for, because you would only need one to protect the circuit. However, there's a little bit of complexity here. So there's a second set of terminals here that say DB, and I think those are for a separate battery that's just for the logic. And you can see there's a bridge link in here that essentially connects the two batteries together, or the two terminals together. And I think that's because if you're using this thing to ignite your rocket, or when you're ejecting these drogues, they might require quite a lot of power, and you don't want the voltage to sag that's going to your microcontroller, because it might force it to brown out and reset. So you might have a separate power, like high current power supply battery, and a separate battery just to keep the microcontroller going if that high current supply browns out when you're kind of igniting the rocket or whatever. Now, I think this can also ignite the rocket itself, but I'm not sure how you would do that. Perhaps you would do that by only having one parachute and then using, say, the drogue line to do that. On the back, we have a few more components. From what I can tell, these are two optocouplers. I haven't traced out where they go. It might be because this is on a separate supply, and maybe they've fully isolated the data and this section of the power. Yeah, down here we have an LD33, so that's probably a low dropout 3.3 volt regulator, and that's it for all the circuitry. So given that they say that this thing is drawing a lot of current, the first thing that you would suspect is a short somewhere on the board. And this project came as a kit, and the students assembled it themselves, and they did it with, in pretty tough circumstances. They don't have a good working area yet. Hopefully we can fix that for them. But even so, they did a pretty good job. You can see that most of the soldering is wetting. There doesn't seem to be any dry solder joints, and there doesn't seem to be any blobs. There's a couple of alignment issues with some of the components. So yeah, you can see, for example, here, this resistor is just a little bit out of alignment, but not to the point where you would expect a short or anything to come up. I might just kind of use a bit of flux and reflow that just to bring that back into alignment. Same for these kind of resistors down here, but nothing that looks bad. I mean, this looks a little suspicious. There is kind of a bridging of that solder out onto this trace, and it looks like this trace is the positive supply, whereas that's the negative battery. So that could be, that looks suspicious. But usually the solder mask will protect you even with this kind of blob here. I will clean that up, but I don't think that's going to be bridging. What I would say though that's kind of surprising is when I identified this part as a FET, well, you can see it's written on the board, but when I knew that was a FET, I looked up the part to figure out which was the gate, drain and source pins, right? But this is the gate pin here. And the gate goes straight into the microcontroller, and I can't see any gate resistor. So normally there is a small gate resistor here to essentially reduce the length of this line, because this line could act like an antenna, and MOSFETs don't need much current really on them to activate their gate. So typically there's a gate resistor quite close up to the pin to prevent this kind of ringing or getting into interference. Especially, for example, when the MOSFET switches, you get a sudden surge of current that might induce something on this gate line. And yet there is this, what's that, 4.7 kiloohm resistor here, and that's connected between the drain and source pins. In fact, this whole thing's a bit confusing, right? Because we have two transistors, obviously to kind of activate these two chutes, and yet the MOSFET is used on the ground here. So it's almost like this is used to kind of, I don't know, isolate these supplies. So a very strange setup. You wouldn't need all three, at least not in a very simple kind of wiring. So there's something to figure out there as to what's going on. So what are we going to do? We'll get this thing powered up, see how it behaves, and see if we can find a short or something like that on there. So I've mounted it there. I've attached two probes. These probes are going off to my bench supply, but they're going via this multimeter here. So the idea is that we're going to have a look at what the current draw is while this thing boots, and if it's very high, I'll turn it off. We'll current limit everything, and I'll use a thermal camera to try and track down where there is a short. Keep an eye on this while I switch on 5 volts. So let's give that a go. Oh. Well, that's good news. Okay, so first of all, that buzzer beeped 3 times, and the only way that would do it, there's no oscillator in here or anything that would cause that to beep in that irregular pattern other than the microcontroller. So that's really good news. I was kind of worried that the microcontroller itself might be shorted out or otherwise damaged, and especially because the student said that this would be warm. But given that that worked, that was actually pretty successful. What was surprising was it was pulling half an amp, and there's nothing on here that needs half an amp. I can't imagine there's anything on here that needs half an amp. So with that piece of information, I'm going to suspect something over here. I wonder if perhaps one of these transistors is okay, or the MOSFET's okay. So I'm going to probably probe around these and just see if these are shorts or if they appear as diodes and do that.
So Marcus here in the edit room. I buzzed out everything using the multimeter's diode mode and couldn't find any problems with the diodes, the transistors, or anything in there. So the next step is to try using the IR camera. My hope is that I can see where this short is. And what you can see is that the heat seems to be generated directly in the microcontroller and a small patch on the other side of the board, which is the voltage regulator for the microcontroller. So it appears to me that there are no shorts on this board other than the shorts that are happening inside the microcontroller. So it looks like the microcontroller itself has failed and is still operational, but is somehow sinking a lot of current through some of its I/O pins. So the only thing to do is try and desolder it. So here's a time lapse of me desoldering this thing. What I'm going to do is try and clean up the board while I'm desoldering it, remove this microcontroller. It's a bit tricky because the microcontroller itself was installed using the legs of resistors, which is a really hacky way of doing it. I mean, it would have been much nicer to use a pin socket, but these are 2mm spaced pitch pins and quite small, so I can understand why you would use resistor legs if you just didn't have a pin socket to hand, but I think the kit should have come with a pin socket. Okay, so here you can see the finished result. We're ready to try powering this up and see if there's any problems with this board itself in isolation. If there's a large current draw, then we can track it down. And I also cleaned up the module itself, and I've cleaned it up to make sure there's no shorts in the pads, just to see if it itself has a problem. So I'm going to apply some power to this, and we'll see if it draws 0.5 amp or so.
So let's power it on. Yeah, so I'm seeing 5 volts and 5 milliamps. I am a bit worried that, okay, I think it might turn out that this module's got some kind of problem, but I am a bit worried that when this module's in place, it's essentially shorting out maybe kind of, you know, these MOSFETs or transistors. But right now it looks like there's basically no current. Yeah, 5 milliamps. So I'll just turn that off again. What we'll do is we'll set up this for probing and see if we put power into this, what the problem might be. So I've got this now set for 3.3 volts. We're going to try and inject power through these kind of PCBI connectors. Let's go. Yeah, okay, so you can see it's pulling 200, but it doesn't account for the full current draw. We were seeing like 0.5 amp. I need to fix this, and quick. They're going to try and launch this weekend. So what I'm going to do is pay way over the odds and replace this ESP12F with something from Amazon. These come with a breakout board and some pins, but we're not going to use that. So I don't have 2mm pin headers that can allow me to solder this in. So what am I going to do? I am going to instead pull apart some pin headers to grab the pins from them. So I have these guys. So in theory I could destroy this and pull these pins out. So let's try that. Just kind of crack these open. As you can see here. You can see they'll come out. There's one pin. Yeah, I'm not sure. Look at that clearance. Way too tight. Okay, so I went ahead and used those pins. And it's not the nicest thing I've ever done. I actually used this as a template. So I would load pins, say in the 4 corners at first. And then once I had pins loaded in the 4 corners, I would solder them in, take it back out the socket, adjust, and then add some more pins, because I tried to get them all lined up at once and that was nearly impossible. So I don't know, it's better than the resistor wire that I saw used in the original manual, but not great. So I'm about ready to try flashing the firmware. You can see I've installed the ESP on its new pins into the actual main board. So you can bridge the pins on the programming board with these two, and I've bridged them on the other side with solder. And then all you need to do is connect ground and TX and RX to a serial port. Now I'm using an ESP prog here, programming board, but I am just using it as a serial port. I am not using it, you can see I've only got 3 lines connected, so I'm not using the enable or the reset control. It's just a serial port. The programmer is beavering away there. Oh, and the upload's done. And it says it's doing a hard reset, but it's not doing a hard reset. What I'm going to have to do is actually desolder that jumper that I put in. So this is the final test. I've powered the thing up. I used the serial port to extract the pin for the Wi-Fi. So if you look on the serial port, you can actually see that come out. So this is the actual name of the device, and under here I have some of the pin of the Wi-Fi. And once you connect to it, you can actually just go straight to 192.168.4.1. So it offers itself up as an access point, and you actually get the control page. So you can see here it's disarmed. I can type in a validation code to arm it. Let's try arming it for a flight, eh? That would be quite funny. Oh, it's armed. Now I get the alert. And I can't seem to disarm it. Can I click arming off? No, that's it. Once we're armed, we're armed. Oh. Okay, look, it's giving me a validation code to... So I guess I had time. Okay, I guess I had some time to kind of clear the area, and then it beeps to tell me it's live. So that's it fixed. The only other changes that I made, apart from installing these pins, I also kind of replaced this with a jumper. I also installed these DuPont connectors here for the battery, just because this kind of soldered in wired kind of connection is very unreliable, and I don't like how far this was sticking out. It looked like it was a short, danger of shorting things out. But otherwise this thing looks fully functional, so I'll send it off to them and hopefully they'll send me a video of it being launched and I can attach that at the end of the video. Right, thanks. Hopefully this is the first of many videos to come.